Perfect. Okay. All right. Good morning, everyone. Just let me move this away because it's here. Okay, perfect. Okay. Good morning, everyone. Today you will have with you Dr. Frank Duschek from the DLR, the German Aerospace Center, and he will talk about biothreats, biological weapon agents, the history, the approaches, and current challenges and case studies. So Frank has cooperated with us. It's been a few years now, many years actually. So almost 10, I would say.
Almost
10 years.
Almost 10. Next year it's going to be 10.
Yes, so it's been a very fruitful cooperation so far, and we're always happy to have him here for projects and for lessons at our courses. So I leave you in very good hands, and have a good morning. Frank, please introduce yourself and see you later. Have a good day.
Okay. See you later, and thank you for the introduction. Yeah. Also from my side, good morning, everyone. And if you don't mind, we will step through these slides more interactively. I would like to encourage you to ask questions if you have some and give comments. Maybe I'm not well prepared enough to answer all your questions, but I hope that I will. I would like to start with my slides. I'm having around 50 slides or so, which is a lot. And some of them are doubled, redundant. And I just would like to... Huh? Doesn't work, doesn't switch the slides. Ricardo, grazie. Ricardo doesn't switch the slides. Oop. And what did you do?
There's something wrong with it, yes. Okay, we'll start PowerPoint again. Okay. All right. Problem solved. Now it seems it works. You can just use the arrows to move back.
The best. Thanks.
Okay, perfect.
Then I would like to show you what I'm going to talk about. First, I would like to tell you how I would like to organize this morning session. And then I would like to introduce myself to you. And I also would like to have get your feedback. Where are you from? Just this would make me feel better, or to give you answers, specific answers to questions. And then I would like to go in deeper into the period for biological agents. We are going to have exercises in between, where I would like to divide you into groups, and you have a couple of minutes to discuss things, then present things, and then we are going to have a common, well, discussion and the workout of answers. So I'm going to have a quick introduction of myself, also about biological agents, and then I'm going to start already with an exercise. And as you will see, my background is in optics. I would also like to address this as a hot topic. What can optics, spectroscopy, lasers do to prevent or detect biothreats? Okay, it's just one slide for me. I'm from the German Aerospace Center. German Aerospace Center is a governmental research institution, approximately like INEA from Italy is. It has more than 10,000 employees, 50 institutes, and more than 20 locations spread all over Germany. And it has for sure also offices in Brussels, Paris, Tokyo, and also in Washington, D.C. in the US. My background, our background. I am located in the southern part of Germany. I can show you here. Stuttgart is my headquarters, and Lamprechtshausen, it's in the forest. There is our lab. We can do things over there that you cannot do in a city inside because you don't have enough space. So, southern part of Germany, and it looks like our center looks like this here. And this here is my lab space that I'm having, and you can see there is also some free space, some test ranges where we can do experiments with bioagents, with lasers, and test those technologies. Our main action, our main goal is to consult ministries and public authorities like the federal police, like fire brigades, for sure the Ministry of Defense, and also the civil part, the Federal Office of Civil Protection and Disaster Assistance. I do not know if you are familiar with this institution, but they are, well, heading all the fire brigades in Germany. So this is our job. And then I would like to go for biothreats. Why do we do research? Why do we have to be prepared for biothreats? Because at least intentional biothreats shouldn't be there. There's a convention, like the convention for the prohibition of chemical weapons. There's also one for bioagents. And it's a convention on the prohibition of the development of production, stockpiling of bacteriological and toxin weapons. and on their destruction. So, and this convention is now 50 years old. So meanwhile, if there were any bioagents, biological warfare agent, then there should have been enough time to destroy them. There are updates on this convention about the member states, and the convention itself is structured quite similar to the chemical weapons convention. Couple of handful of articles and clearly structured what to do with chemical agents and what with biological agents and what not to do. But one can discuss this: is this convention a toothless tiger? It's only can be regarded just as a memorandum of understanding. No, there are no real duties for each member state. There's no control mechanism and so on. That's a problem. Besides from that, this is on bacteriological and toxin weapons. There are, especially today, there are enough examples that there are also non-weaponized biothreats. We have had it 2 years ago with coronavirus. So then, matter of definition, what are biothreats? Then is it only warfare agents, or is it something different? So we have to extend it, and there's a definition of the Robert Koch Institute from Germany, how they treat biothreats. These are threats of biological origin that could have grave consequences for the health of the population at a large scale, which means a biothreat is large. What is large scale? Is it for millions? Is it for 10? Is it lethal? Does lethal mean it's a large scale, or is it, well, you just have a quick short disease, one single person, and then it's fine? Is it still large scale? So the definition is very not very specific. And I have Googled, by the way, how to fight such biothreats. And that was really funny. If you Google it for biothreats, then you get such an image. And they claim we can fight biothreats with classical weapons, machine guns. So sure, you know, all that's not possible. Okay, biothreats might be due to natural catastrophes. One that you can see here in Germany happened in 21 in the Cologne region. A huge flood And as we've heard over there, this flood caused fire threats. Almost everywhere where's water and some not too cold temperatures. The probability that there will be a bacterial growth is much higher. So they stated Ahrweiler 21 was a bio threat to the public health in Germany. According to the definition of the Robert Koch Institute, at large scale. This is only the flood here, this picture is only a minor excerpt of the true event over there. So a standard flood is one. We know that diseases like coronavirus and COVID was a bio threat for the population. And then there's also the bioterrorism, which is why my department is being funded by the German Ministry of Defense. We all fear bioterrorism because we do not know the consequences. So this is a quick introduction. What am I going to do? And before I'm proceeding with a bit more detail, I would like to get to know you. And if you just could tell me your names and your background in a few words, I'd appreciate it. So if we can start here on the first row.
Samuele, I come from the industry, from Fincantieri. So I'm a security manager and I'm Italian. My background is political science and criminology.
Thank you.
My name is Michele Castrilli. I live in Latina and work in here, Latina. From a some firefighter. My background is biotechnology.
Your background is biotechnology.
Sì.
Okay, perfect.
Sono Dario, I'm Italian Army. I'm at the MBC school in Rieti.
In
Rieti,
Rieti.
near Rome.
Yeah. Thank you.
Morning, I am Otto Lucio Franco. I am included in the Italian Army and I work in the Rieti in the embassy school.
Also Rieti. Okay.
As follows, in the Netherlands, work at forensics at police, and also with the team leaders of our national defense investigation to screenwrite your security evidence.
Thank you.
My name is Senator Shamsi from the United Arab Emirates, chemical engineering background, and I am working at the weapons.
I'm going to basically analyst as a company, and I have a background in business science.
Okay, thank you.
Good morning, Manuel, Italian Army, training branch specialist, and a background in political science.
Morning, I'm Duschek, Italian Army. I'm a platoon leader in the 7th Regiment Civil Maintenance, Vigil Topic.
I'm in the Navy, by police civil. I have a background in nuclear physics.
Okay. Okay.
I work at the National Emergency Crisis and Self-Management Authority, and they have a bachelor degree in genetics.
Thank you. So, yeah. So I would like to go on and I have added to my collection of slides, I have added this slide here. Because I think an incident, you have to view incidents from different perspectives. The perspectives are how can you detect or declare an incident? How could you fight an incident and avoid it? And for the future, become more aware of a potential threat and prepare for that. So it's really focused on these 3 points, and it's very, very broad. Natural unintended releases, diseases, but or the intended one, which is really a bad thing. And then also you have to divide those incidents. Where's the origin? We all know the discussion. What was the origin of the coronavirus? One, sure. Then was the question, was it intended? Was it an accident? Still, it's not known. There are only suspicions. Then how transportation, how did the virus manage to come to Europe?
By flights.
By flight? Yeah. Sure. Sure by flight, but how was the transportation between the planes? There was first, I imagine, well, disinfect everything, every surface with alcohol and so on. Wear mask. What is it? Was it efficient to wear a mask or just to stay away from each other a bit?
Just to delay.
Just to delay, yeah. Did we have to wash our hands, clean our hands with alcohol, or was just simply soap more efficient?
It's a good question.
Yeah.
We have so many answers. So
We have many, many answers. Because at this time in 2021, 22, there were thousands of publications of experts and so on, and studies which were, in my opinion, were not final, which were not finalized because the time pressure was really high. People had to know how to behave. So scientists and engineers, they gave advices, preliminary advices, but they were not, most of them were not efficient. Some were, some.
for sure, who did countries that did not put in action countermeasures in the first phase had to take them very quickly because
Yeah.
they had very bad experience. UK, Sweden.
Yeah, absolutely right. So all those effects on transportation, we know by most of the transportation of the diseased people came by airplane, but when I mean transportation, I also mean transportation of the virus itself, or the, and then how did the what were the effects and what were finally the countermeasures that we had to take. So it was very, very versatile. And it was very hard to bring in a structure. So what I would like to do now, and I hope I have a statistics, I didn't find it, but I have a statistics that in average, every 10 years, there's a pandemic threat happening worldwide with more than 1 billion deathly people.
Once
Every 10 years, where at least 1 million people pass away. You can, I think I have published it somewhere in a conference paper. So it's going to happen again, but now last pandemic threat is 2 years away. 2 years. So let's forget about it. It's not important anymore, and let's focus on bio warfare threats. So, and biological warfare agents. We can distinguish between living agents and non-living agents. Living agents means they can reproduce themselves. Which might be bacteria, viruses, fungi, and so on. And non-living are toxins and biotoxins. The difference between toxins and biotoxins is biotoxins are produced by living biological material, which means mostly bacteria. Then yeah, and what is a biological warfare agent? How do we interpret it? And this is clear. It's any microorganism, virus, infectious substance, or biological product. These are biological products. That may be engineered as a result of biotechnology or any naturally occurring or bioengineered component of any such microorganism, virus, and so on. And for sure, these agents have the potential to cause death or severe diseases. So, and just for my background, I studied many, many years ago at the university, and I'm a physical chemist. Started in chemistry and then went more and more into physics. And when I first had contact with bio stuff, then I was a bit upset because the manifold of the paper, the phylogenetic tree of life is clear. But when you can go deeper into all these into this tree and see how many bacteria we have. It's million or 10 million types of bacteria of different stems. So it's very big. And each of those bacteria is huge. From a chemist point of view, it is it consists not only of one chemical component, hundreds and thousands and millions chemical components. So, and it has a morphological structure. And there are only a few molecules that are tiny that chemists actually like and love. Some of them NADH, ADP, and so on. All fine, but you have to distinguish between chemistry, physical chemistry, and the biological part. So bacteria have their typical sizes. They are around 1 to 2 micrometers in size. They have different shapes, spherical, rod-shaped, for example, and then much smaller are the viruses. And actually, this is funny. This slide here is 7 years old. This is the rotavirus, very similar to corona virus. And the rotavirus is much, much smaller, or viruses are much smaller than bacteria itself. 20 nanometers to 300 nanometers in size, which is really very, very small. And well, and they have a certain structure with a core and an envelope around. And in this case, there are also some kind of spike material around. Yeah. And then we are approaching the tinier stuff, the toxins. Toxins are typically not larger than 100 nanometers in size. But still, from a chemical point of view, huge, really huge. It has a 3D structure and it is highly toxic. So this is what we are dealing with. And our research is how to detect such agents, such molecules. Can we do that? And here is a summary of those agents. The chemical composition, they all contain proteins. Most of them contain lipids and nucleic acids. And for sure, bacteria and viruses are well structured. And I said, my background is physical chemistry, and we have an optical lab in our department, a huge lab. So we are dealing with what can we see, and if we want to see something, we have to use light for that, for sure. So, and the light can be absorbed, scattered, or transmitted. And when the light hits material, there are different types, different mechanisms. What happens with light? And the light can interact with the material and induce vibrations or electronic transitions, or the light can be just simply scattered. And all this stuff can be measured. And it can be measured on, depending on the wavelengths, light properties like polarization. You all know from photography, some polarizing filters. That's how we use it. But it also depends on the particles itself, on the size of the particles, on the shape of the particle, and it also depends on the time you measure. So many factors that are involved and many information that you can extract from that. And if it is possible to get the information, all this information on a protein which is really large, huge, at least for some certain point, we may say this is a protein from bacteria class X or Y. So and the bacteria classes are listed here. Very prominent is the Bacillus anthracis, which can form spores, and it's long living. Therefore, but these are the main, in overall, these are the main interesting bacteria for bioterrorism. Please, if anyone has another example, let me know. Okay, and what makes them so critical? Some of them form toxins, and the toxins here are it's one example, the botulism-forming toxin with a little dose of 3 nanogram per kilogram weight. You cannot put this on a scale. It's just a very low amount, 3 nanogram, which means for 100 kilo person, these would be 300 nanogram. On the other hand, ricin is also a toxin that is very popular. You will see an example later on, or we're going to have an exercise later on. On ricin is 22 microgram, which means it's still very toxic. But the botulinum toxin is 1,000 times, around 1,000 times more toxic than ricin. Okay, and then is the question of the transportation mechanism and the infection path. It is not a threat if you watch, observe, find these agents by light, which means seeing them. You don't have contact with them. But it is, for all of them, inhalation is all that goes into your lung is critical into your lung, and then it goes into your blood. Also, the eyes is typically, eyes means direct contact with the eyes. Is a path that is critical, and then you have also everything that goes into your blood might become critical. This means inhalation, if someone is around coughing or so, then he exhalates these types of agents, and others might inhalate them. So, and this is the critical part. Here, you start one guy gets infected. He doesn't know that he's being infected. He feels well, and then he goes somewhere where he meets many people. This is this has been the infection path, and for corona, again, this slide is older than coronavirus was. And then they will exchange the same air, breathe the same air. This guy originally goes to hospital, but all the others, they don't, because they do not know yet that they are being infected. This is the critical thing. So, and it's really surprising for me that we have, or all the community has pointed this out many years ago, and there was no countermeasures up to then before Corona. So now I would like to ask you questions, divide you into two groups, please. Left side and right side. If I'm going to, if I was a bad guy, and I would like to prepare for a bio threat, what would I need to do that? I would like to give you your 1, 2, 3, 4, 5, 6. Okay, 5. So right side, left side. I would like to give you, let's say, 10 minutes. Discuss it. What would you need? Expertise, infrastructure, and so on. What would you need to prepare for a bio threat? If you were one side, a state actor, and you are a private actor. A state actor means a state like for example, Timbuktu, or China, Russia, or Italy, or Germany, one single state, and you want to prepare for a bio threat, and you say you are a private actor, which means a terrorist, non-state actor.
Yeah, attacker.
Attacker somehow. What would you need to prepare for a bio threat? Okay. So you're having exactly 10 minutes, please.
Insieme a destra finisce subito la devi continuare. The security sì.
Patient zero. Un po' di matematica per pensare come funziona un errore veramente una fissa che un piccolo genere che da questo principale ma mi usano questi quattro e poi loro passano every place then in space for the space, just narrowing down what.
Yeah, we have been accepted. We can work with friends, fine, and so that's what I accepted being outside, and the region, the organization. Yeah, the thing is, we need to have what you never exactly without the confirmation. We can't hear you. Yeah, we'll be by floor.
Yeah.
No, by the. Well, you know, so you. Yeah. No, I was.
Get into the deployable ones.
Yeah. Injuries.
That's prevention, for example,
Those are very.
I think it's the you need the warranty.
Yeah.
Yeah, the warranty, but also put it and warranty, you have to have listen, but to decide where it's.
You mentioned that we should have kerosene areas. Oh, so that's, yeah.
Yeah, when it's actually something like that, it's of staff.
Yeah, those wheels.
Yeah. And we do the original type of and software features of the so how the many with okay.
The thing, in communication between
Fine.
extra supply, stock.
But I think 99% alone are very sufficient.
Okay.
We have to defend. We have to defend, so that's the value.
You have to, what which you are a stimulation, a fan guy, you are the fan guy. Because we understand, we.
Sure, I think you got us. mixed up.
What would you think? What would you think if you take the day, Russia would prepare for?
Okay.
I think we didn't spend any
That's some time.
Yeah.
We were preparing with defense.
Classic slide exercise. We need
Yeah, but
Methods of delivering.
Yes, how it's
yeah, we bought like this, but I also did some some partner, some.
Darkness.
So that's what it's but
One of the ways.
I think 100 for
The minimum is important thing. So I would actually go ahead and make it. 79. That's it.
Give you everything with
Maybe worth something.
This or cheese?
Yeah, what is the most from you live the world of society and it's capable.
and also not it's also I know.
Yeah, with
You with the distribution, you will forward. Then you can The subject. I think
Which you
have an upgrade, it's not you go see lots of photo.
drones far more efficient.
I'm sure it's standard, because otherwise we don't know. So I don't know. It's so that you make the one from school here.
So I was not inside. So we see. And they do the song, the engine that they
Okay. Okay then. Before we're going to have a short break, I would like to one of each group to present or somehow summarize the findings, the discussion.
After the women.
Uh,
But no, we're the non-state actors, so the state should go first, as we say.
State should go first. You're absolutely right, and you are also in the majority. So, and one thing, I will write down some keywords, and when you prepare for the next exercise, when you're doing the next exercise, then I will put those notes into a slide, and you will have it. I think Colomba also will share all the slides. So, please.
I have been appointed but well, we misunderstood it first, so we thought that they were attacking us. So what we would do, but basically it's more or less the same things we think that we will need. We will need knowledge for sure, like biologists and those kind of people. We need research facilities with bioreactors and laboratory, good medical facilities, quarantine areas. We need a scientific policy. We also need a communication plan. At least that's what we thought of.
What you need?
Well, it's a scientific policy, so how to deal with it and whether to share it with the public or not. That we involved this so much. But we also need a communication plan. We thought if we are being attacked, but how we are the attackers. So
Okay.
Communication strategy, because we are, let's say we are attacked. And we need to have a stock of personal protective equipment and vaccines, which they feels being used because it's backfire and all that stuff. And it's nice that we are safe. And then we figured out we are the attackers. So we first need to get clear what agents we will use. And
Did you find make a decision for an agent?
no, because we are still, well, we're thinking to make the tech a bit bigger, because first thing is, what we call it is, what's the plan? Do we only want to interview people and cause occurrence and panic? Or do we want to cause many victims? So we, the last one, we decided to go for the water supplies, because we are attacking. So we didn't know what kind of agent to use, and we were still discussing on how to deploy it. But we already determined that it would be a covert attack. Already due for the insider, so it doesn't really, it's really showing that we are a state actor that is doing this. And so basically that's in a nutshell.
That's very clever.
Because we presume that if we would use fire weapon instead of both. Okay. To us.
Okay. Then thank you. I hope I have everything on the buzzword keyboard written down. I will put them on the slide. And also the others from group 2. Oh, thank you.
So, since we are here in Rome, we decided to organize our attack in Rome. So we considered to use as an agent Legionella to first of all to conduct the attack in July because of the Guilty Bear. We decided to spread the Holy Saint Water, the main church in Rome, and in the main fountains. So we are 5, so we divide the duties in a 5 small group. We have 4 months to obtain enough quantity of the Legionella, because they can buy a laboratory that we are going to create probably in we have 4 months. And then after the attack, so with a delay of 7 to 10 days, we are going to communicate via social media our attack and the reason why. So to determine a spread terror within the whole city.
Especially in Rome.
Especially in Rome.
This would have a huge impact. Rome is famous for its good water. So, yeah.
And also it would be all around the world. It would be for the Jubilees, so people would be flying back and forth.
Yeah.
So the panic would spread not only in the epicenter of the country, also in Rome, and it would be widespread before the world. We hope.
I hope not. Yeah. Okay. So, very interesting. I did not expect this here in Rome, but it's a very interesting approach, and I hope that it will never ever happen. But this shows us where our society is open for being injured by such simple measures. What question is, what kind of competencies would you need to spread such a
Question, a biologist, a So.
A simple biologist is fine, and he or she could make the job.
To prepare a culture, so we need a laboratory.
Laboratory. Okay. And this is.
It's quite simple to tell you that.
Okay. So, thank you. I would like to ask you to have a break, a coffee or whatever, or let's say 15 minutes. And we meet here at 10:20. Yes, if you show me the coffee machine.
Yes.
Some coffee. Come. I'll wait for you downstairs.
Even on both sides. Yes, it's
So,
il studio autista come essere solo che vabbè,
okay, so I would like to mention or to highlight some additional challenges that we are having, and some of them I already have tried to highlight, especially the complexity of biological matter, and that this matter is for living bioagents. It changes over the time. So nothing is fixed. It changes. Bacteria are living and they grow and they die or form spores and have a reduced metabolism. And then as a biothreat, you have additional vectors like mice, for example, who can spread those agents. And then that's what we have discussed also earlier. The incubation time is a point. Your group has made use of the incubation time. You put your message on social media 4 to 10 times later after first effects can be seen. So these are additional points, challenges that we have to consider when detecting something. And now we are switching immediately into the next exercise. I think this is much clearer, and it has the background of a German incident. And I would like to read that with you. It's happened in June 2018 in Germany, also in in the Cologne area. A Tunisian national was arrested, and it has an Islamic background. And police investigators found ricin prepared in large amounts in this private apartment. They were just looking for that, and actually they also found it. They got some hints before about by the intelligence, and that's why they were looking for rising. So please answer those questions. It's quite similar to the exercise that we have done before, but now from a different perspective. You want to detect rising. know that there is some toxin threats inside this apartment. Which properties should a detection system have, or if we know or if we suspect that there was rising inside this apartment? So again, this is group 1. Group 2, which properties should a system for the detection and identification of an unknown agent, bioagent have? So it could be anything.
I don't understand, what does it mean, for properties?
Properties, which properties? What would you expect? What feature should the sensor have? Should it be a handheld device, a tricorder device, Star Trek, or should it be a PCR device that's mobile?
So we have to decide the infrastructures and the materials and the equipment
Yes,
for the detection, the identification of the agent.
yes.
Okay. This, okay.
And this is for you for rising. You expect that there's only rising, and you expect that there might be any bio threat inside this apartment.
Qualsiasi cosa, noi andiamo senza sapere anche quella 50 specie per persone che si
That's what I can make. Yeah, it's fine. That's fine. Gas and but there is no like this, that's on the spot from everything. We didn't like things.
Yeah, I just have the.
80% actually.
Yeah, it's
I think
it's. This.
like a PCR.
No, these PCR are like fish.
Okay.
PCR.
What's the start? And
And then this is like
on the spot.
yeah, because for instance, we know some. If you then.
Say, oh,
Well, I just found it's not always pretty. So I mean, just.
I'm sorry. Oh, that's I know shit for you. Okay.
And then each information maybe you can see.
Very fun.
Make more positive. Okay, then there's education, right? Everything. So extra. Difference. Yeah, right. So that's also. That was this. That we are in the part of the information that you have. And then you have something. It's straight from the. Well, that's be definite. Only if you go to other, but it's really important. To be honest. Be careful receive this. So even if Friday, so correct. Okay, but you do that, we will military, so the military ones you never have also. And so when you look at finance. But there's a lead burden. So that's what we did. We didn't sure. That one. And so we have the virtual information. Whether you was able to make a spot in the superiors. We have to get frustrated.
But you didn't have the intention to use it.
No, just like, I think I can make it.
So I felt funny.
Yeah, so he was able to, yeah. But then he made it, and he felt like, correct, well, she.
So in Italy, the student the list, the name. Io capturo no, video ormai fare richiesta della ricerca del as long action implemented action features from you remember this we said report is a good police.
One more minute.
No, questo ce l'abbiamo. Basta che teacher riesci a questo ce l'abbiamo. Esiste siamo continuando. Yeah, sì, ma c'è il giancolo. In Italy,
Because some water treatment from
good this one.
Okay then. At this time, I don't want to ask you for your answers for your results. I first have another slide that you should take into account. And this slide here is, in my opinion, the most important slide that the most important information for you as a takeaway. If you ever come to the decision what is needed to detect a biothreat, then you can ask yourself how those 12 bullet points. Very important. And the first thing is for the biodetection, is it time critical? When do you need the information? Now or in 12 days after incubation time is over. Then where is the threat and where are you positioned? Do you want to be, can you take the risk? Is it a risk of being in direct contact with the biothreat? Yes or no? Can you have contact with the threat, with the agent? What is the required sensitivity? This means, do you have for the rising, for example, in this in the rising example, the police officers might have seen the white tumbler somewhere on the table or on the bench. So in this case, the sensitivity requirement is not very high. You don't have nanograms or micrograms or single bacteria or so. Then next question, do you want to distinguish the agent from other material? Are you looking for the needle in the haystack? Then for sure, what is the quality of the information? Do you want absolute numbers or just with a probability of 90%? There it is, Bacillus anthracis. Very important is the phase. Is it solid, liquid, as a suspension, or in the gas phase, which means actually aerosol? Then environmental conditions, all that's around in the room or outdoors. Yeah. And then who is going to work with the device, with the detection device? Is it you? Or is it a highly trained scientist who would be the only one in the world who can operate the device? I think this is probably not the best choice for a real threat. And then actually one more points are for sure the cost of such equipment and the availability. Is it still under development? Is it on the market but in a different country where you cannot buy it from? So these are questions that you should address. And now we are stepping back to the slide to the slide before that you answered, that you discussed the question on. And I first would like to have your comments on question number 1, but with a focus on these points. So, who would like to do the job from group number 1?
Yeah. As well. No. But it's that. It's it's a little bit fun. But looking at it from the Dutch way, which is not always the good for it, it's just to keep it simple because you already have the information and there's probably Bryson is over there. So that's why and you look around the premises, you do research, which can give you some extra positive results on the rice team. So you like find castor beans, castor oil, white powder, whatever, a specific area where you see that some safety measurements are being taken, so that you can give some pluses to the information that you already have, so that you know that you're on the good side. And then the way how you do it is just to keep it simple, so you can do some presumptive testing. And I don't know if immunoassays is possible with rice team. So if you see it in the client, I mean, it won't be a really small amount of it that you really have to look for, even if your return is like very like it's rising. So there should be a fairly amount, so which is more than enough for the detection level for your immunoassay. So you can do the immunoassay, get a presumptive positive on rising. So then you can do the sampling and then have it tested in the laboratory, so you get a definite analysis of it, so that you're sure that it is rising. So that's how we do it with too much. But
I think it makes sense what you said. I also I think most states I can see for Germany they would go for that way. The point is, how would you protect yourself? First, my start point is
the beverage system, probably, with a heat filter. Of course,
why is that?
well, because you suspect the biological agent.
We suspect rising.
No.
We suspect rising. Do I always need? Do I always need a full treatment mask if I go into a biocontaminated thing? Do I need it in general? Or is it just a precaution?
But if you don't know that it is veterinized. Yeah.
I mean, the first one was into the thing you make before identifying and making sure that this, you will have to have that. So,
Yeah, you go to the next one and then you can store them.
yes.
And you have probably also noticed on one of my slides I have written privacy is toxic when inhaled. Yeah. And when the first slight wind in this apartment might create aerosols. So better have full equipment first, responders, and what well, it's not the white powder. Yeah, you don't want to bring it into your lungs. So, absolutely fine. Thank you. And it would take, how long would it take? What would you think to have information on the kind of threat inside?
If you have the immunoassay, it can be within minutes. So from a police point of view and from a prosecutor, that would be really good
Yeah.
And then, so you can secure everything, you make it safe over there, and then just wait for lab analysis.
Yeah. Okay. Second group.
So we are going in suspecting it's a biological agent, but we don't know which one. So first thing, we would have a PPE for maximum protection with filters and everything. So that would make our time inside the hot zone. We would call it for maximum 30 minutes or something. We would include enhanced sampler, capture by street sampling equipment in general. We would also bring some chemical detector just in case, because we suspect it's a fire agent, we're sure of it. And we would be inside the area or unit, as I said, it would be contact free for maximum protection. We would want the results as soon as possible, so that is why we are bringing a biocapture one that is portable and a layer sample that could stay in the oxygen for an hour, about an hour. So we could get some preliminary level type of the results immediately, and then we would send also sampling to the lab to have second level of like for the experts to deal with. But since we don't know what it is, and we suspect it's bioagent, we want some sort of idea of what we're dealing with. And more or less this is what we came up with.
Thank you. And also the question, when would you expect the results?
Depends. We have two types. So on the one hand, we have some immediate results that are not highly precise with the biostrip and the biocapture. But we would send the sampling to a lab and we would hope to get the results back in 2 weeks max, because we need the incubation period maybe.
Okay. Then I'm having another question. Where would you take the samples from?
From the apartment.
Yeah. Where? At
We
all
have
over?
two different, one is air sampling,
That's something?
then we have swabs from the major location, and if we see, or we think we can see, for example, if we were ricin, it would be a powder. So if also with the ability of the operators, if they can detect something that is suspicious, then we'll swap that as well.
Okay. That's good, and I'm very fine with that. And where would you make the swaps where you do not see where the particles are? Where would you do them? Would you have a strategy to do swaps, one time on the wall, one on the floor, and one on the table, or take a whole swap of all the surface?
No, but we would have a strategy, which I'm gonna refer to my military colleagues that can take back. And probably similarity which by. So to be cost effective.
Because from the swab sampling, I need I don't know, a powder or a liquid. You know, when okay.
I would suggest that the table and the repository analysis.
But actually, if you cannot see it, you have to speculate somehow and make a best choice.
For example, in an indoor bar.
Because you are not, you are under time pressure, like approximately 3/4 of an hour of time, taking swabs and all this. Well, secure the evidences that you are having, get a first impression, and then take the swap and so on. Documentation is important. So it's not easy in this case. And if you go for crime watchers, they typically, if there's blood, and if there's blood somewhere, they spray their fluorescein around, and then they have an ultraviolet lamp, and then you see it glow somehow, and then you can take the sample. That's nice. It doesn't work all the time. And this is what we have, or let's say from my perspective, have learned to support first responders with equipment that might help them to come over those time-critical scenarios. Let's go for biodetection. And there are two, you can distinguish between two approaches in biodetection. One is standoff detection or laser-based detections. The other one is sampling with point sensors. If you have optical technologies, then you may take advantage of light speed. Which means you illuminate your target, your zone, and you get a direct response. What's happening over there? What kind of substance agent do we have? Since bioagents are very, I have pointed it out in the very first slides. They are huge compared to chemicals, and they are complex, and they are also, if you go for bacteria, they are mixtures, and they change in time. So, but at least you can classify those information a little bit, and you can probably distinguish, oh, there is a bio-like agent at this place, and at another place it is not. So you have the opportunity to localize hotspots or potential hotspots, and then you know where to make the swap, where you have best chances to take the swap. This is possible on surfaces, and this is also possible for aerosols. But this technology helps for the classification. It won't substitute the classical technologies like sampling, the laboratory analysis, and what the point sensors can do. They are very sensitive and they are very specific, but they are slow. It takes 2 weeks to get full information. But their identification capabilities are unbeaten yet. So you have to grab the local information and feed them here, and we know where to take samples and make sure I'm taking the sample and I'm having a thread that I'm going to get to identify in the future. Okay, and then there are a couple of technologies, sensing technologies for detectors, and there are optical ones. That's what I pointed out, optical technologies, and then there are traditional technologies, and there is always a fight between selectivity or specificity and the sensitivity. And some machines are very highly sensitive, but they cannot distinguish between agents. And also vice versa. So, and only few are here on the top right. They are both specific and both sensitive. But drawback, you have to take a sample. You know where to take the sample. You have to take it, and then you have to have time. But once you have defined the radius of the threat and the local extent of the threat, then you can well be safe. You can stay away from this local extent. So this is a main thing, and this also you have to consider these types of detectors, because here we had it. If you have no time, if you have no time to lose and you want instantaneous information on the threat, all the other things are gone, and these are only optical technologies that remain. So if I was a first responder, my first wish was having such a device, one of those, and see where the threat is. And then take the other devices. Make this culturing technologies, which are time consuming. We know bacteria need to grow. But also that's what we have learned during the corona pandemics. Also the PCR, even if it's called real-time PCR, is taking time, a lot of time, typically 1-2 days when you are fast, else more than that. So time is what you need. And then if you have an aerosol threat, an airborne threat, then you can count particles in the air. And you can classify them afterwards with mass spectrometers, gas chromatography, and other stuff. In a combination, that's already feasible. That's done. But the most sensitive way is still if you have bacteria in the air, and if you have only few colonies per milliliter, then let them grow and reproduce themselves, and then you have the requirements, the sensitivity are not that high anymore. So again, it would take time. So What do we have here? So culturing, 7 days, PCR, 6 hours, which is very optimistic, in my opinion. Biotechnologist, what do you say, 6 hours? Is it a low number or a high number? What would you say? It's high? What would you say it's reasonable for PCR or average number? Three hours? Okay. So please remember this curve here or this diagram over there. Question again for the requirement list. Safe detection distance required. Do you need standoff capabilities or in situ sampling? Do you know where the agent is located? Can you see it by eye? Then it's easy. But if you don't, if it's in the air or really tiny droplets on the wall or so, then it's not easy. And also, when do you need the information? Now or in 3 hours or 5 days or 10 days? We all want to go to the right way, and there are technologies that I would like to present you. That I would like to present you after 5 minutes break.
My drink again. My stomach has.
Did they use a presumptive test first? And then sample this to the floor? Yeah.
John.
Yeah.
This is exactly.
And they in charge.
They were in charge,
Yeah.
also as the other instances. But yes, there are, it's a federal, they are organized in a federal manner,
Yeah.
and there are experts from all over Germany. It's for this case, in Cologne, people from Germany had to come over to Cologne. You know, full mountain, full dress, fully safety, as a letter. You had to come over because really it took 3 days or so to analyze everything. So I would say quite complex.
Yeah, okay. Because I was just thinking that if you left this in the house, it would be a police thing, and we have our team within Dutch police. So I was thinking that because you should also do decontamination, but if we would have a special weapons and arrest to go in there, it protects to apprehend the suspects. I was like, okay, but then so you can do it quick eco units, but I know that it is special procedure inversions that you can contaminate people in. So I was already thinking that, okay, if we have these amendments, then one of our teams enjoy some of this testing and to move, okay, so what is there? Because if you use never say them and it isn't, it should be more than a few nanograms per trillion is there, so you can see it. So, especially when the rest of the year is, we can do the search, do some testing, and meanwhile, we can have a container or certification unit that's placed somewhere. So I was just thinking, how did your ladies do this?
They did not really do it very effectively. It was already in the media, and they still did not know where it was spread in this apartment, how what they decontaminated. It was still open, and there were interviews with the Tunisian guy. But they did not could not give the information.
How lethal is this area? How lethal is it if it is airborne? So
microgram.
yeah, so
kilogram, a kind of body weight.
Yeah.
So if you're roughly 80 kilos, you can say it's 1.6 milligram.
because I was thinking, and this is the way how I tend to work. If suspects, yes, because I suppose that a COVID operation was in front of this investigation. So if our observation talk, it's the suspects go in and out of the house, you know, it isn't. Because then they would be dead. So that's why the job that is fairly safe.
When I absolutely right, but no. I see this powder like chalk.
Yeah.
Like chalk. If you open the window,
Yeah.
it's aerosol.
But even fast movement.
So you have to make a decision. In the case of like in a standard mask, face mask would be fine.
Yeah.
But you never know.
So,
And
no, I mean, that's fine.
I can tell you, they did not. They handled it in a manner that was safe for all responders, but they did not handle it very quickly. It took 3 days to be sure they have all the contaminants.
Yeah.
And they could decontaminate it.
Okay.
Not easy, and it sounds to me, there is some rising.
It's a nice place. Yeah.
نحن نشوف ما يعطونا كم بالمية؟ زين
تخيل اصلا جو ما يمدي كانوا مسويين ملتقى الموظفين
زين
فاول شيء كانوا مكرمين في فئه شايف البيت وما ادري شنو في الموظفين كانوا يشوفون هديه فاوتشر مكتب سفريات عشان ثلاثه يلا ما حد سفرني عقب كان في طلعه عجيب طيران الامارات كانوا جايين شيء طلعه كان يطلع اسمي
اللي صار زين اوكي
بعد 10,000 ميل عطوني
اوكي زين
كانوا حلوين يعني اصلا قبل رايح الطيران ما في يوم كريديشن ما اعطوني كان خصم ما اقوى خصم
صح مع حياتي ما تبغى كيري من الجيش وانتم تحصلون 20% ديسكاونت
شوف مرات
يعني مرة اللي 2 ونص 2 ونص تجي نص عن صار مدري ما استخدمها المفروض بس ما تخيل الكل ما يفصلون
بس لو أخذ شيء لازم يصير مكتب طيران واحد مو مكتب سفريات مكتب طيران واحد.
هو ماشي كويس صح بس قاعد
بغيت
بس التوقيت اللي ابجريد عليه عشان تذكرها
بس يومين تصير
هم مدلل
لا مكتب عشان طيران.
اوكي والله 20% اوكي يعني اوكي
نظيف يعني أكثر من نظيف أي حد في البطاقة
ايه
يكون عنده بطاقة بس تكون فرعية.
ايه صح
مرات يمشون عادي يسوون
ايه
خواتي سووا خصم علي. خصم ببطاقتهم علي عادي. يعني أنا أسوي البطاقة. مرات يحسون لا أنت والله بطاقتك رقم 2 مو رقم 1 والله مسوي.
وحسب الفضل
هي على بالضبط. أنا كنت صايرة أسوي لها خوات كلهم في الجسم. كلهم في الجسم. وعيالي ماشي عادي. أنا حسبت إنه أنا أحتاج مزاج.
شكلي بعد
لا شوف
ايه بيصير اليوم غيب بعد شيء هذا بيصير بس من هذا لا والله اذا خلصت بيصير قريب مليون شيء متواجدين ها؟ بس المويه تقدر تجي كمان فهي واجد بس الشام إيه الشام تحديدا وين هذا الصوت بس تقول لي باطل يعني ده اللي كان اسمه حتى لو كان صغير شكله بتنجان هذا زين لا اوكي شو تبين زي ما بغاض انا عيان ابدا بس مثل ما قال مو مشكله واجد قالت اوكي شد الخلاص شليتها خلاص كلها بشكل قلتين بشكل هذه مبررات ترتيب هذا شو ترتيب يا تحب تفصل يعني
So, okay, the others are still down for smoking, I think. But I would like to go on because I'm having 20 more figures.
So you cut the dot. Yeah, I know it's this. Yeah, he's again.
Here are some laser-based standoff sensors that might be used with bioagents. There are LiDAR technologies. Who knows what LiDAR is? LiDAR?
Oh, LiDAR, okay.
I don't have iPhone, but it's on your iPhone, so you can also scan something like 3D laser class.
Yes, exactly. That's what it is. You use it in iPhone, or you use it also in automotive to the distance sensors and so on. They work with LiDAR technologies and for autonomous car driving. And this can be used. This LiDAR technology can also be used to detect aerosol clouds. And in 3D to see how the density of such aerosol clouds is. It's not just for bioaerosols, but also for gas clouds, smoke, and so on. You can see this is a cloud. It's 100 meters in diameter, and it's the main concentration is in the center on the front side. That's what you can do with LiDAR.
thinking from a first responder point of view, it doesn't work as a LiDAR function on your iPhone.
These lasers here, these LiDAR lasers that I am speaking about are not the lasers that you have in a small iPhone. You know, the laser pointers for presentations and so on. These are also not lasers like this one. They are more bulky, much stronger, and you need some different power supplies. But anyway, the principle is similar. So, and it's not very specific. You can detect aerosol clouds, but and the shape and the structure detect it. But what you cannot do is to distinguish between smoke and bioaerosols, for example. And there we are having different the differential absorption LiDAR. There are many other technologies that you can use as a on top of the LiDAR technology. Where you have a higher specificity. This technique called LIPS or breakdown spectroscopy, it's, I would say, it's good to, this technology might work in a closed environment. It's not eye safe. You produce a focus and it's a plasma. It's dangerous to operate. So it's not a full recommendation. And then you're having two other technologies, fluorescence-based technologies and Raman scattering. And these are getting more and more prominent. The fluorescence, everybody knows it from, I do not know, everybody from a clock that's on the wall and that's shining at night. This is fluorescence or phosphorescence effects. And the light is very specific for biomolecules, for bioagents. They all have a signature, and once you irradiate bioagents with ultraviolet light, they glow in a certain manner with a blue and greenish color. So, and you can use this technology easily to find and localize bioagents. Very good to have, and especially maybe one of you just let me show you this one here. Next one. This here is the fluorescence from bioagents, from bioaerosols. You can see it by eye. It's very, very characteristic. So let me go on with this. And Raman scattering is the most specific technology. You can use Raman scattering to really identify single biological cells. You can state this Bacillus anthracis, and you can also state which stem is it. But what you need for that is a Raman microscope at this moment. So this is not really standoff. I would like to show you, this is Raman spectroscopy. You can do it on distance, and you can do it in the microscope, and the microscope is very effective, and you produce after a few seconds a spectrum. First, after 10 seconds, it looks like this. 20 seconds, it's more characteristic. And after 1 minute, it's fine. And it's a very specific fingerprint. That's what you can expect for the future. And then I would like to come to a more sensitive technology. This is fluorescence. And fluorescence means you irradiate something with a laser, some sample with a laser, ultraviolet or blue laser at least. You irradiate it, and the molecule is in a basic state. Then you put in a laser, and what happens? The laser somehow the light gets absorbed by the substance, and it's going to be in an excited state. And there it stays, relaxes somehow. The energy, or something has to happen with the energy. So it relaxes somehow, but not fully. And then it relaxes finally fully and emits light. This is the fluorescence light. And this light is characteristic for bioagents, for biomolecules. It's not very broad since those molecules are complex. But it has a full advantage. You just need to have some kind of ultraviolet light. And this might be the same lights that the policeman and have to identify blood. If you do it with a laser, which has much more power, the detection is much more effective and sensitive. So this is a perfect candidate for detecting something and localizing something. A disadvantage, an identification is not possible with this technology, since many bacteria fluoresce the same way. The color of the light, the fluorescence light looks the same, so cannot distinguish very well. But that's not a job. We just want to find the location of the suspicious agents. So this is how it looks like for a small chemical molecule. This is characteristic, but for a big molecule like this one here, this is just NADH, which is in every cell or living cell, in every living cell, and then these signals that you return, they look somehow very broad, not structured, not specific. Here, these are the same. This looks the same. So, but it's good for localizing. It's not just good, it's excellent for that. And you can also distinguish, depending on the color of the laser light, on the wavelengths of the laser light, you can distinguish, is it a living agent or is the metabolism, is it down? So this is the good thing and the application of fluorescence that you can use, and still you have to consider your list of the 12 points. Remember them. And one question is, this technology is good, it's eye safe, just a lamp, maybe somehow a laser, a small laser. Then you have a standoff, you stay away from the threat. And you can somehow classify the stuff, but you cannot identify it. So you can optimize this technology when you use different laser wavelengths, and when you measure more parameters than just the color of the fluorescence light. You can see you use it as also as a laser ranger if you use pulsed lasers, which is actually then radar or LiDAR technology. It's then combined, and you can can extract information on the shape of the particles. So, but one thing is, you always have to know the information that you want to extract and the complexity of the overall scenery. How many potential hazards do you have? And what is the background? Do you want to detect bacteria in soil, which would be very hard? Or do you want to detect bacteria on some glass plate, which is easy? And then how many bacteria do you want to detect, distinguish from each other? And the more troubles you have, the lower is the probability that you are able to detect these kind of threats. So simple, keep your scenario as simple as possible when you make your choice. So I'm skipping this one here. It's about classification, the information that you may extract, machine learning stuff, and so on. But the next slide might be interesting for you. About distinguishing between agents. Here you are having let's say three bacteria types: Bacillus subtilis, thuringiensis, and the E. coli. And then you're having different other agents around in the atmosphere, which might be oil, diesel in the air, or rapside. Yeah. Right?
Yeah, right. Yeah.
It's a spring. It's very yellow, and you can produce oil from it. Then
Vegetable like oil, but if you do it
Ah.
it's
Is vegetable diesel.
yeah. And then you also have other pollen and so on. So, and if you want to distinguish them all from each other, which means you have, in this case, 1, 2, 3, 4, 5, 6, 7, 8 different agents that might occur, and you want to know, is it Bacillus subtilis or is it E. coli? Then you can train an algorithm, and from your measurement data that you acquire, you would have some information. And if you have it for those 3 bacteria types, then you see sometimes the prediction is Bacillus subtilis, but in truth it's E. coli. So this is an error. And all these, the diagonals here, they are true findings, true positives. So the majority is clearly true findings. It's very, very nice, but you do not want to have those false negatives here. So, but is this really the information that you as first responders would need? And in my opinion, it's not always the case. Maybe it's only important for the first responder. Oh, this is bacteria stuff, and the bacteria stuff is not good in the air. So you can summarize the 3 bacteria, and you can summarize the oils, and you can summarize the pollen to different classes. And when you have summarized them together, then you have a perfect answer. You have no more errors. You know that your measurement is a bacterium. You do not know exactly if it's Bacillus subtilis, Bacillus thuringiensis, or E. coli, but you know it's a bacterium. And this is not a this is not what we want to have in the air, in the atmosphere. And I would like to show you now an experiment just to see about demonstrating how this works. This is a sketch over there. We use a laser system. It's quite old, the setup. It's 15 years old or so, but it's a very nice example how it works. We have a laser system here and a telescope, and we shoot the laser, the violet line, onto a sample that we do not know what it is. Shoot the laser onto the sample, and then light is being scattered back. And we collect the light with telescope and analyze it. That's all you should need to know. In this case, we do it on our test range. And yeah, we do it on our test range. We can do it. At a distance between 20 and 100 meters or so. And here is a video how it looks like. And it's very, let me see how I can start this video. They're very spectacular because this is how the apparatus looked like. Not more there. It's much more compact right now. And this is my colleague, my former colleague, and she put a sample on the table. we do not know which kind of sample it is. And then it is irradiated, and you get back a feedback after a couple of seconds, and what you get is red or green, nothing more. In this case, red, which is the substance class. And here I would like to show you this demonstration in more detail. From these, some random samples are being taken, put onto the workbench by our biologist, by Lea. She stays. She puts them on it, and you see, all I want to do is distinguish between chemicals, plants, oils, and bacteria. And that's how it goes. Nobody's there contact-free with technology.
20-meter distance.
20-meter distance. The thing why we did it in 20 meters distance is because there was a working test in a neighbored test stand, and we could not extend the range. We can go to 100 meters. So that's how it goes, and this is the potential of this technology. And this video is quite, it's 10 years old or so. So technology has far progressed. What you see is it takes less than 1 second to get an information and localize it. But please also judge it's here. This is, we know where the suspect sample is. Case of ricin, we also assume that we know it, but sometimes we do not know it. Then we have to make a laser scan over the surface. But this is easily feasible in nowadays. Okay, then I'm having a. No, I think we should. Maybe we should. No, we should skip this part. We do not have the time anymore. I just would like to resume the main things. The biodetection, if you want to detect threats, please think of standoff detection and sampling or point sensor detection. Keep in mind what they both are good for. One, very good for localizing on a wide area, on surfaces and in the air. Imagine you have to take, we have an aerosol cloud in the air, an aerosol relief. And then you want to know what we have, or you want to protect a sceneries from incoming aerosol, or potentially incoming aerosol. How do you detect those aerosols? You cannot put hundreds and thousands of samplers, air samplers, in front of the detected space in three dimensions, you know. That's simply not possible. And the aerosol cloud is not cooperative. It won't go, likely won't go to exactly the place where you want to have it. This is where you have the sensor or the sampler. There's no guarantee for it. So it might go another way and then you cannot sample it. So that's why standoff optical technologies are excellent. And then you have sampling sensors, and every time you know where the fission sample is, then you can take these sensors. Take a sample, take a swab, no matter, or do it with an electrochemical sensor or whatever. No problem. This is less expensive. This might be fast enough to detect it. So this is critical. And always, really always keep these points in mind when you're making decisions and you ask yourself, why has the choice been taken for a GCMS or an aerosol sampler? Keep this in mind. Is it the best choice that you detected, or when you have to buy something for detection? What's the money that you have? Is it available? And so on. And optical technologies are more and more available. Still, it's a upcoming technology, but these technologies are more and more available. All these bullet points need to be checked if you want to have the perfect decision at this time. Good. Then it's 15 to 12, and this is my very last slide, but everyone who has questions, contact me. Contact me by mail or even phone, doesn't matter. And I would also like to, once you are going for your master thesis, to last some more months. But if you're going for a master thesis, and if you're interested, apply for that. You can make the master at our facility, either remotely or in part-time. This is possible. And see what we can do. It's developed. This would be more development, innovative stuff. But you are encouraged to contact me if you like. Me or Andrea Malizia, Colombo, Pasquale Gaudio, all fine.
Thank you very much. Thank you.
So, and I think that they will share the presentation with all of you.
Frank?
Yes,
Frank, can you hear me?
yes, Ricardo.
Yes, okay, yes, I confirm that we will share the presentations as usual. And please wait for me for 5 minutes and I will come in the classroom.
Okay, all fine.
Okay.
Thank you.
Thank you.
Ricardo. So, what is coming next? Is it, next week is free for you at the university?
Yes. The university, yes.
But not, long.
We go back to work.
You go back to work, yeah. Well, not me, in Germany, we also have Carnival,
Carnival.
yeah. So next week will be, well, free, some vacation days.
We came out of the carnival tracks.
Yeah, I think the main weekend is now, when I'm curious when I get back to Germany tonight. All the people are somehow dressed in a very crazy way.
And we have been on the tennis carnival. Yes, it's a mess. It's a now also due to over tourism at the COVID. Then you see literally you can't work. So and everyone dressed for carnival. It's the interactive of and that is this moment is
In the Cologne region, it's also very pretty. They have, they start the carnival season on the 11th of November. They started, and then it's getting increasingly more and more and more. And typically 1 week before the carnival weekend, you cannot work together, cooperate with the police company. They are out of order. Oh.
But the same year, I don't know, 19 dollars.
Yeah, I hope that I cut off some slides. Okay.
Okay.